Now we will be calculating hash for the block. So calculation of hash we will be doing after this function. So this will give you a synchronous arrangement. So calculating hash is done with a function named calculate hash. So now I'm calling for a function that is calculating hash of blocks, basically blocks which are present inside the blockchain. So the variable name will be variable calculate hash equals index, and it will call for previous hash, and then it will set a timestamp. So my timestamp will be set over here, the parameter will be timestamp, and then comes is the date. So with these parameters we are going to start with our function logic. So basically calculating hash is nothing but returning a 256 byte character. It's like hashing up your value, encrypting your value to a 256 byte character. So this will be done over here inside return, and the value is ConnecToPeers dot, the function is SHA256, which converts your data in 256 byte character. Converting is basically done from the hashing format. So it is done over here as index plus previous hash and concatenated with timestamp plus data, and this all values will be represented in the format of toString because it is inside in the hash format. So it is important to be represented in the string format. So for converting a value in string, we use toString in JavaScript. Now this was for calculating your hash, but when it comes to calculate hash for a block, so that is done with the function. This is like calculating hash for current block, I can say calculating hash of current block. But when it comes to calculate a hash for block, so that is done as over here, that is calculating hash for blocks, which is done as variable calculate hash for block, which is equal to, it takes a parameter of block and then it is sent over here with the values as return calculate hash, then it calls for block dot index, and then it checks for the next value, that is block dot previous hash, and then it checks the value, that is block dot timestamp. So this is for calculating the existing block which is present inside the blockchain, and afterwards comes block dot data. So once this part is clear, we have calculated the hash which is needed for it. So this section is done. Now the important value, which is like we have calculated the hashes for the current block and the blocks which we will be creating. Now it is also important to add a particular block. So adding a particular block comes with the logic of first thing is validating your block. As mentioned, once the transaction is completed, it can't be changed, it is immutable. So when we try to tamper a particular transaction inside a block, then it will definitely become an invalid block. So for checking whether the block is valid or not inside the blockchain, we have the associated function, and that we will have a look in our next chapter. Now we have calculated hash, generated the new blocks, but it is important to add your blocks inside the blockchain. So for that we will be doing it after the latest block generation. So we have calculated this. So now get started with the add block function. So that is done with the variable add block. Because we have created the blocks, it is important to be added up somewhere. So we will add this block over here, and afterwards I'll call for my function. So it is done with this variable which will take a parameter, that is new block, and this parameter will call for the associated values, and that values will be inside a if condition, that if if this block is valid or not. So how it is considered as valid, that we'll have a look right now. Valid new block, which will take a parameter new block, comma, get latest block. So once this is set, if this block is a valid block, then I will push it inside the blockchain. So I'll set my blockchain dot push, and the value will be new block. Okay, once this parameter has been decided, we will calculate now this function, that is valid new block. So this is nothing but a function to test if the block is valid or not. So that is done with the is valid new block function. So it will be variable is valid new block equals new block, comma, previous block. These two parameters will be taken over here, and then the next situation will be to check if condition, that is if previous hash, instead of previous hash we will take previous block, because we are calculating with blocks. So if the previous block index plus 1 is not equal to the value of new block dot index, then I'll print a console, that is console.log invalid index. So once this part is done, we automatically get the values, and we will also return a parameter of false. It is important to return some particular parameter over here, and then I'll set the next thing is else if previous block dot hash is not equal to new block dot previous hash, then I'll print the console. This is to check that if my hash is not matching with the new block which I have created. So this can happen in this situation when we tamper a particular transaction. So now I'll say console.log invalid previous hash. This is to justify that my block is valid or not. And again I'll return a value, that is return false. Then there is also one else if condition after this. There comes the next else if condition, that is else if. Now it will be calculated as calculate, the function which we had, calculate hash for block, and there I'll send a parameter of new block. If the calculate hash for block is not equal to the parameter for new block dot hash, which means that if my hash of the previous block is not matching with the hash of the previous block, exact hash value, the way we always create the blockchain, well, in that scenario we need to print console.log type of is a character where it converts the parameter of object to a necessary parameter which is required. Type of calculate hash for block new block. Basically it is a type conversion parameter. And now I'll again print console.log. The next value will be to justify that it is an invalid hash, and it will be done with the parameter for calculation as calculate hash for block with the parameter of new block. So once this is done, we need to also append our new block. So that will be done using new block dot hash. So once this is done, we'll set a return parameter as return false. and after this, outside all these conditions, we get return true if it is not matching to any of these conditions, which means that my particular transaction is not being tampered. So it is a valid transaction. So that is why it will return true. So now in the next chapter, we'll understand the output and we'll create ConnectToPeers section, and we'll understand the output, what we'll be achieving after creating the complete blockchain structure. It is important to connect to your peers whenever you develop your latest block. So as in the previous chapters, we discussed about various type of parameters like calculating the hash and getting the latest block with the hash parameters. Now we'll create a variable that is where, just taking it upwards. Now it is connect to peers, this function. And this function we will be calling for creating new peers. Basically, peers are nothing but the node connections which are involved in the block. Connect to peers, and now the parameter comes over here is new peers. And this parameter will call for the functions. Now here we will create new peers with the help of for each loop. So that is new peers dot for each. So it will be for each, and now the value over here for each should be proper. This is like calling for the for each element, so it will be for each. The element will call for the peer. This is my peer, and the peer that are WebSockets and the init connection with respect to HTTP. So we'll be doing that here, like new WebSocket, and the parameter over here is peer. And after this comes the next thing, which is to put your WebSocket on the on state. So we'll call for the function on, and we'll send a parameter that is open with the parameters which is equal to init connection with the WebSockets. Now I'll again even call for the error parameters, and that is also sent with the on response, where I'll be giving error with the values. Now it will call for the error which is mentioned over here. The error message will be the method inside a console, so that is console.log. The connection is failed. So this is the connection priority which has been set. So this part is about the connection priority. So I have created a function for connect to peers. So this part is done. The next important thing which comes over here is like whenever you're building up a particular blockchain, it is important to use some functionalities with respect to broadcast and other parameters. So now we'll create a blockchain with this parameters, that is where write equals, the parameters will be nothing but ws message, and it will call for the next value with the send parameters, that is ws send json dot stringify, and then it will call for the message parameter. This message will be used for the broadcast network, because whenever a blockchain is created and when the mining is being successfully done, it is broadcast on your particular network. So now I'll broadcast it over here as where broadcast equals message. The message will be broadcasted here, sockets dot for each. The parameter will be nothing but socket with the value of write, and here I will write the necessary socket message. This is usually done whenever you are interested in giving the socket message for the WebSockets. So it is being done now. Now it is important to connect to my peers, so I'll call for the functionality that is connect ConnecToPeers, and here I'll call for the parameter initial peers, which was initialized, and then I'll start my HTTP server. And after that, the next important thing comes over here is to start the P2P server. So I'll do over here as init P2P server. So my functional logic has been completely designed inside main.js. Now how to run this particular code and how to get the Genesis block which we have designed over here. So let's go to our command prompt. So this is our command prompt, and over here I'll just signify over here that I need to start my package. So that is done with the name npm start. So npm start will start your particular resource package. If there are any errors, it will be depicted over here. So it will just check for node, that is main.js, and these two things, that is the one which we printed when we call for init server and P2P socket. Over there we mentioned that the port number will be specified over here, which means that my application is running properly. The next step, which is very important to understand, is to go to that value which we have created for now. So let's go over there and understand the hash values which we created are properly visible or not. So that is done with localhost 3001, and the blocks which are created are redirected to the block section. Now when we call for this particular URL localhost 3001 blocks, we are getting the Genesis block which is being properly done. So it is like the initial block which we have created, it is properly available over here. Now how to keep on adding new blocks? That is also a big question mark. So you're linking with the previous hashes. So this is the new hash which is generated because it is getting converted to a particular string format, and that is visible over here. But whenever you are focusing on a hash format and creating the previous hash and connecting it over here, so that will be visible in the peers section. But for now, we don't have anything because we have created only Genesis block. The overcoming next block is an empty array, that's for sure, because we haven't created the other blocks. We only have the Genesis block, and that is clearly visible over here in the JSON format with the block structure including index, previous hash, timestamp, data, hash, and these parameters are using cryptography functions as well, the plugins which we install for getting it done. Now when it comes to projects, you can use curl and keep on adding up a value over here. So curl is basically used in Linux platforms like Linux distributions, but it's also possible in Windows. And over there you can keep on adding up these values and generate the value which is needed. And once it is available over here, your previous hash for the next block will be this one, and it will generate its own hash, and accordingly your blockchain will be available over there. These blockchains are not tampered, but once it is tampered, it is not a valid blockchain. It's an invalid blockchain. So in this way, you can generate your own blockchains with respect to JavaScript, and you can produce the output as the way we have generated it right now.